Ladies and gentlemen, hi. Well, how to create secure code pipeline is a pretty complicated story. To be honest, it can take hours and days even, but we have limited time in our conference today, and we will just define main milestones or minimum scope of work we need to do in order to define secure code pipeline. My name is Leon Maister. I'm technical expert at Checkmarx, and before we will learn or understand why and how we need to protect our pipeline, let's take a look on security landscape. What's going on? It's internet not working well, so I have a screenshot. It will be okay for us as well. We can see the screenshot that shows which data breaches or significant events occur during the last period. As you can see it according to the history, and this information presented by kind of bubbles, and each bubble shows the size of bubbles show how security breach event was significant. What's important to see that we can see a representative from different verticals. We have something from technologies like Microsoft. We have something from social media like Facebook. We see Facebook's twice. We see government like India, a government office. And what's important to understand that all these big companies invest significant budgets to protect the data, to protect the systems, and still we see a very significant incident that occur in industry. It means we need to find very sophisticated way to protect our application, and I suggest to focus in three most important verticals or surfaces. First, we need to scan the code we write in order to protect it, to verify there are not vulnerabilities there. We need to scan the code we use. It's open source libraries, and we will talk about it deeper today. And additional surface is infrastructure, as code is provided or deployed to the system. During this deployment process, we can detect additional issues as well. So we have three. We have own code we use, open source libraries, and deployment process. Okay. In fact, the process of code writing can be separated in a few steps. First is design done by developer, team leader, internal discussion. We have code creation. In fact, during our IDE work, like Eclipse, Visual Studio, IntelliJ, and so on, we commit our code to the storage, to GitLab, GitHub, Azure, and we run build to build our product and deploy it to the market. In each step in this process, we need to perform action to protect our system from vulnerability and or from malicious threats. In fact, I can count or I can define three types of threats. First one is mistake we are human, we make mistake, and in parallel with regular bugs that developers do that affect on our functionality, the bug can be occur as or can cause to vulnerability. The attacker will exploit it. For example, it can be input validation that cause to parameter tampering vulnerability, SQL injection, and so on. Let me give you some very simple and straightforward demonstration how vulnerability in the code can be exploited by attacker. I use OSP, known vulnerable application that each one in industry uses to check security code solutions. But in our case, let's take a look or learn how parameter tampering can be exploited by attacker. For example, I'm going to buy TV from eBay or AliExpress, and I see the price for one unit is almost $3,000. So if I will choose 2 TVs, I need to pay $6,000. I hope you see in the back of auditorium, $6,000 and so on. But what will occur if attacker will intercept this request and will change the price of unit from almost $3,000, let us assume, to $10, and will forward this request to the server. As you understand, for 2 TVs, attacker will pay just $20. So the system topology here caused to parameter tampering vulnerability, and the attacker can exploit it. So we just come back to vulnerabilities. From mistake, oh, I need to put this one, it will be more comfortable. Mistake, by the way, this mistake can be done in your own code, developer can do it, or this vulnerability can be in open source library. But we as security officers, as developers, need to protect or be ready to deal with this type of bugs. Other type of threats that can occur is malicious. It means that somebody prepare threat for you, trap for you, and try to exploit your system. And there are a few types of malicious we can discuss. First of all is typo squatting. Somebody prepare internet site with very same name like your site, just with some typos or some missing S or something letter reversed. And if victim will visit this site, sensitive information can be stolen. Other type of malicious can be presented like malicious takeover. It's a very short story that occurred a few years ago. Who is working with crypto use very popular library called event stream, and the developer that developed this application or this library post or they publish any post that say, hey, listen, this is the last version of the library, I'm not going to develop it more, and I'm going to new project. Suddenly appear some individual in GitHub with name right hand control, contact the owner and say, hey, you're fan, I like your library, I know the code, I can keep continuing develop it. After the original author transfer rights or control to this library, after 2 or 3 releases, the guy, right hand control, published library for 2 million downloads and stole the money from Bitcoin. Bitcoin wallets. So this brings us to second type of threats, mistakes, malicious, and one is a misconfiguration deployment process. It can be done in many ways. The DevOps engineer is key person to protect the system, and the misconfiguration can cause to system be exploited. Okay, we define which type of problems we need to detect, and now question is when and how we can do it. So the first option or first requirement is do it early as you can. It means shift left the testing to the developer. For example, put it to IDE. You can run the scan in your IDE environment and receive results ongoing. So developer will be able to see results as soon as possible. And by this approach, we resolve issue of do it as soon early you can. The second approach, you need to scan your code often. It means it's not enough that developer will scan his own code in his development environment. Code on SCM, GitLab, GitHub should be scanned as well. It means while you run the build, as part of build process, you need to run security scan. Because if I, developer of a user interface, and I scan my code, I did not find vulnerability, but somebody else from my team developed business logic and data access layer, just concatenation of all these scans all together will allow me to see vulnerability that starts from user interface, business logic, and data access layer. So we need to put scan process in a pipeline. And the next request, it should be automated. Developers, and I personally write code almost 20 years, developer can skip any step that system not enforce him do it. So if we wish the system will be scanned early, often, it should be done in automated way. And if I come back to my first slide, we can see the all step of development of code repository and build system should be tested automated, and we should train our developers how to avoid vulnerabilities in the code. So if we know that we should perform tests, which technology we need to apply in order to reach it? So most common today is scan the code you write. In this purpose, and we can find tons of standards that define which type of vulnerability can be detected. Here we see top 10 very basic standard, and you see that from time to time the order of vulnerability is changed. For us, it's not so important in which level of vulnerability is, but all 10 of them should be detected by system. So we need to use high quality static code analysis tool to detect vulnerability in our own code, and which information the system should provide. It should provide, first of all, vector attack. We should be able to see which vulnerability exists in code. I should to see it in my code itself. It will be very nice if system can identify all your code automatically languages and provide the best place to fix your vulnerabilities. So security officer and developer will see almost automatically where in his code we have a vulnerability that can be exploited by attacker. The second aspect of what to test is code I use. Probably you will be surprised, but most code base today is include open source, and open source is written by humans, and humans can make mistake, can make vulnerabilities, and between 60 up to 70% of overall code is open source code. And in this open source code, by the way, according to statistics, it's about 2 million packages already available in these managers. And this open source code, or dangerous or threats this code bring us, can be separated into logical blocks. First one is, I already tell this story about contributor that take over other account. And let's come back to presentation. So this is malicious code, but in parallel or on top of malicious code that can come from attacker, we can have mistake in code that prepared. And very good example is heartbleed bug that occur and exist about 2 years. During 2 years, this vulnerability was available for attackers, and this vulnerability exists in open source cryptographic software. It's holy place for each security officer, and it took 2 years to detect it. It was a very significant issue, and we remember Log4j that occurred just few months ago. So open source library can bring very significant effect on our system if it's compromised. So it's impossible to scan every library. You see, it's 2 million libraries analyzed. It's impossible. We can use libraries just approved by our security officer, but it's very restrictive. It's very complicated to manage it, and the right way to use effective software composition analysis tool to analyze open source libraries, and which information we should receive from these libraries is again very straightforward. We know to get the list of vulnerable packages. We should see license details for any particular package. We need to know how to fix the problem. We should to see which efforts I need to done in order to resolve this issue. This approach will assist me to prioritize my work, and very useful if I can see where in my code vulnerable or problematic code is used. And additional to SAST and SCA, we're talking about infrastructure as code. Today, while we use so many Dockers, Kubernetes, Terraform, whatever, you see a very interesting post. To make error is human, to propagate error to all servers in automatic way is DevOps. So today, DevOps engineer is key individuals to protect something unlogical, because DevOps is not his main job, but modern application and process how we deploy our system calls to DevOps person to switch and be DevSec ops and protect the system from different type of, for example, with one of misconfiguration. Okie dokie. So we need to use SAST, we need to use SCA, we need to use YAC. Two approaches can be applied on to involve or to build our protected security pipeline. I mark it by different colors, for example, 2 vendors, and you can choose for each technology. Take the best vendor you can find. For example, you found best for SCA, best for SAST, best for YAC. And this approach is working. In fact, if each vendor provides best results, you can use it. It makes sense. But this approach has few weak points. For example, it's very complicated to coordinate them together. It's very complicated to correlate the results between a few technologies. It's complicated to integrate it in one single dashboard. Other approach that can be done is use platform. For one trigger, you analyze code for SAST, for SCA, for KICS, for API security, for supply chain, and you will be able to correlate results between technology. You can create one single report to see it. And the way how we suggest it is just put your technology to review results or to get results in one single place under one single platform, while developer will have access to education platform to learn how to write non-vulnerable code. He will be able directly from development environment scan his code for all type of threats, and on top of it, in automatic way, you will be able to initialize scan directly from source repository or build management system and scan it for all spectrum of threats, SAST, SCA, YAC, supply chain, API security, Dust that can be integrated with API security, and review results and take one single holistic view. This approach, I think it's more efficient. This approach is much easier to implement, and each corporate should understand that each company has a budget challenge and resources. I don't say each one need to start from all pool from beginning, but if we define, as I mentioned in the beginning of my presentation today, to define milestones, I think, ladies and gentlemen, this is a way where we should go. Training, and in fact, it's all. I'm available. You can come to me. We have our two representatives here, Ches and Dimitar. They're from commercial, so if you wish to meet them, ask them, please do it. Thank you very much, and I'm open for questions after it. Thank you.